I have always been curious about how solar panels convert sunlight into electricity. It turns out that solar panels are actually very similar to batteries. Solar panels are made up of several layers. And the layer that produces electricity is called a solar cell. A solar cell consists of two layers, a negative layer located on the top, and a positive layer located on the bottom. The negative layer is made of a mixture of silicon and phosphorus, which makes this layer have an excess of electrons, while the positive layer is made of a mixture of silicon and phosphate. This mixture lacks electrons, so it creates an electron hole that can attract electrons. When we stick the negative and positive layers together, electrons near the contact area will fill these electron holes, which will create a new area at the junction of the composite layer and the positive layer, called the depletion region. In the depletion region, all the electron holes are filled with electrons, so they are in a state of balance and their charge is also in a neutral state. This area will become a barrier to prevent the excess electrons in the upper area from flowing down, and then we let light shine on this solar cell. Light contains photons, which trigger the release of electrons from their holes in the depletion region. The released electrons move upward, while the electron holes move downward. Therefore, the upper region now contains a large number of electrons, and the lower region contains a large number of electron holes. When we connect the upper and lower regions with a conductor, the electrons are attracted to fill the electron holes below, and the electrons that have filled the holes below move upward to the depletion region. This process will continue to repeat as long as there is light shining on the solar cell. Therefore, the power generation in the solar cell is caused by electrons entering and exiting the electron holes. The electrons naturally move toward the electron holes, while the sunlight releases the electrons from the holes. Through this mechanism, a continuous movement of electrons is generated. This process is called the photovoltaic effect. The solar cell is then mounted on a conductor plate at the bottom, which is the positive terminal, and a conductor strip is installed on the top, which is the negative terminal. Now, this solar cell already has positive and negative terminals. Next is the anti-reflective coating, which prevents too much sunlight from reflecting and allows more light to enter. This coating is located below the negative terminal. Solar cells are arranged in series within a panel. The number of cells in each panel can vary, with panels of 36, 60 or 72 cells. The amount of electricity produced by a solar panel varies depending on the intensity of light that hits it. Under normal lighting conditions, each cell can produce 0.5 volts of direct current. So you can calculate how much direct current will be generated if 36 cells are connected in series, and then calculate how many watts of power it will have.